Given that 5e to the x equals 3, find the exact value of x. So the exact value means that we don't have a decimal answer at the end. So e to the x would then be 3/5. If we take logs of both sides, we get ln e to the x equals ln 3/5. And ln e to the x is just x, so that's x equals ln 0.6. Find the exact solutions to the equation e to the 2x minus 7e to the x plus 6 equals 0. If we substitute y equals ex in, we find we've got y squared minus 7y plus 6 equals 0, which is a quadratic equation. So if we factorise that, we get y minus 6 and y minus 1, which leads to y equals 6 and y equals 1, which means we've got e to the x equals 6 and e to the x equals 1. And of course, anything that results in 1 when we're talking about powers must mean that the power was a 0. For the other one, if we take logs of both sides, we get ln ex equals ln 6, and of course ln e to the x is just x, so x equals ln 6. Solve the following equation. 3 ln x minus ln 9 equals ln 3. So the first stage is we're going to make 3 ln x into ln x to the power of 3. Then we're going to use the log law to make it into ln x to the power of 3 over 9. And now we're just simply going to remove the logs from both sides. So we get x to the power of 3 over 9 equals 3. So x to the power of 3 equals 27. So the cube root of 27 is 3. Solve this equation. Give exact answers. Equation is ln of x plus 12 over ln of x equals 7. Now if we multiply through by ln of x, we'll get ln of x squared plus 12 equals 7 ln of x, which is another quadratic equation. So let's rearrange it so it equals 0. And now we're going to substitute y equals ln of x. So we get y squared minus 7y plus 12 equals 0. This factorises to y minus 3, y minus 4, which gives us y equals 3 and y equals 4, which means ln of x equals 3 and ln of x equals 4. So if we do e to the ln x on both sides, we get e ln x equals e to the 3, e ln x equals e to the 4, which means x equals e to the 3, x equals e to the 4 are our two solutions. New wildflower is introduced in a meadow. The number of wildflowers is W after t years in the meadow, and this is modelled by W equals 32 e to the power of 0.4 t, where t is greater or equal to 0. A. State the number of wildflowers planted originally. So originally means when the time equals 0. So that would give us W equals 32 e to the 0, which is just 32. So 32 plants originally. B. Predict the number of wildflowers after 5 years. So that means this time t equals 5. W will equal 32 times e to the power of 0.4 times 5, which is 32e squared, which works out to 236 if we round that to the nearest whole one. Predict the number of complete years it would take for wildflower plants to exceed 500. So that means W we're going to say is 500, and that's going to equal 32 e to the 0.4t. So if we rearrange that, we get e to the 0.4t equals 500 over 32. Now let's take logs of both sides. So we get ln of e to the 0.4t equals ln of 500 over 32. So that's really just 0.4t equals all of that. And therefore t itself will be ln of 500 over 32, all divided by 0.4. This works out to approximately 6.8 years. So we were asked about complete years, so this would really be 7 years.